this. It is a trig function, so I'm going to graph it as a trig function. What do we see about the graph? We notice that the graph goes up and down and up and down. So what happens as x gets larger and larger? The function continues in the same motion that we see on this graph here. This is just we could piece this graph together over and over again, and we know that the function is going to continue in this same cycle throughout everything. So as x approaches infinity, it's not approaching a specific number. It's just going on in the same pattern all the way through. So this limit does not exist because it's not approaching a specific number. Now, how does this change things? Well, let's look at this graph here. If we look at this graphically, it's the same function we had before, with the only difference being that now we have cosine x divided by x. And what does that do to the graph? Well, it definitely looks different, doesn't it? If we look at it, it looks like there's an asymptote at 0. Would we expect that from looking at the function? I think so, because the denominator is 0 when x is 0. That tells us we have a vertical asymptote. Just looking at this graph initially, we would think that it has a horizontal asymptote somewhere, because the function seems to be flattened out here as it goes to the ends. Well, let's think about what's happening here. In the numerator, this is fluctuating between the number 1 and -1. It's never larger than 1. It's never smaller than -1. What's happening in the denominator? It's getting larger and larger. So we've got a number that is approaching a number in the numerator, this 1, and the denominator is getting larger and larger and larger. So what do you think that should mean is happening to the entire function? The entire function is getting closer and closer to 0. And if we think of this as our rules, the lead coefficient is 1 in the denominator. We don't have a polynomial in the numerator, so it has a degree of 0. The highest exponent is in the denominator, therefore the limit is 0. If we look at it graphically, that seems to support our answer. If we look at a table set of this, again, we can look at the table set around the number. We can begin at any number. We're only concerned about the larger numbers. So let's talk about, let's try to look at those numbers, starting at maybe at 9,000 and continually going up. And what do we see? It's a -9e to the -5, which that means a decimal and 5 zeros and then the number 9, which is a very small number. These are essentially becoming 0, and if you go down far enough, you'll get to a point where your calculator can no longer calculate it, and you would get 0. So both graphically and numerically support what our algebra says, so we can conclude that the limit is 0. Okay, a real-life problem, one of the first we've seen here. Suppose that this function measures the level of oxygen in a pond, where f of t equals 1 is a normal unpolluted level and the time t is measured in weeks. When t equals 0, organic waste is dumped into the pond and the waste material oxidizes. The level of the oxygen is found by the following function. So we've got a pond that normally it has 100% oxygen, but something's been dumped into it and it's caused the level of oxygen to go down more. So what do we do with this? What percent of the normal level of oxygen exists in the pond after 1 week, 3 weeks, 12 weeks? What is that asking us to do? Well, the 1 week, 3 weeks, 12 weeks, that's a unit of time. We would measure time in 1 week. And it said up here time is measured in weeks. So this is really just asking us to find the function value at 1, What is f of 1? What is f of 3? What is f of 12? So we can use our calculator if we choose to find this. So I've got the function typed in. I'm going to do a table set. We're worried about from 1 to 12. So if I start at 1 and go up by 1, I should be able to get my answers out. And it says 1 is 25.25, which is 25%. 3 is 25%. And if we scroll down, 12 is 75%. So that tells us by looking at this that the oxygen level after 1 week had dropped to was at 25%, and after 3 weeks it had dropped further during week 2, but it had come back up to 25%, and after week 12 it was up to almost 76%. So that's what we're asked to do in the A part of that. What is the limit as t approaches infinity? Well, let's look at this. Looking at our numbers, they're getting larger, it seems like here. Let's look at our algebraic rules. The exponents are the same, so we can look at lead coefficient of 1 over 1. So we would expect it to approach 1, which would be the same as 100%. Now, looking at this algebraically, mathematically, will it ever get to 100%? No, because this number on top is always going to be a little bit smaller because of this minus 3t than what's on the denominator. So it'll be close to 100%, but it will never be 100%. Does that make sense in the real world? Yes, because can you get all of the pollutants out of water at any given time? Probably not in a pond setting. It would be very difficult to get it to actually pure water. So it does make sense algebraically. It makes sense that it's approaching 1, but not getting there. And real life, it makes sense that it's approaching 1, but it's not getting there. The limit as x approaches infinity of x to the third, and the limit as x approaches negative infinity of x to the third. Now these are polynomials, so we don't have an expression per se for them. I mean, we don't have a rule for them per se. We can write this as x cubed over 1 each time. Okay, now we can use our rules. Where is the highest exponent? It's in the numerator. So then the answer is either infinity or negative infinity. So how do we determine which one it is? What happens when we put larger numbers in here? A large number approaching positive infinity is a positive number, and a positive to the third power is going to be positive infinity. What happens when we're approaching negative infinity? We've got a negative number to the third power, so it'll give us negative infinity. So anytime you've got a polynomial, you need to be sure and evaluate it thinking about the sign, whether we're approaching negative infinity or positive infinity. It will make a difference on some problems as to which way, what the answer is, whether it's positive infinity or negative infinity. All right, we're asked to graph this function, which you should do on your calculator, and I've got it graphed here on mine. Then evaluate these limits down here graphically and algebraically. So if we look at this limit here, the first one as x approaches infinity, that's moving out in this direction here. What does it look like this function's doing? If you zoom out more on your calculator, I think you'll see that it seems to be going up higher and higher. So the graph seems to say that it's approaching infinity. Now what does our math say about it? We've got the highest exponent in the numerator. Go back and look at your rules. The highest is in the numerator. It's either approaching infinity or negative infinity. Well, let's think about what kind of numbers we're going to have here when we're putting large positive numbers in here. The denominator is going to give us a positive number. The numerator, since this is squared, it's going to determine what the sign is. It's going to be a positive times 4, so it's going to be a positive number. So our final answer should be positive infinity. So we've looked at it algebraically, we've looked at it graphically, and both of them agree. What about approaching negative infinity? Looking at the graph on this one, it looks like the function is continuously going down. So we would conclude from that that it's approaching negative infinity. Does our algebra support that? If I put a negative number in here, negative 1,000, negative 10,000, this is going to be negative in the denominator. What's happening in the numerator? Again, the x squared term is going to determine what the sign is. Because if I take a number and square it, it's always going to be larger than the number itself as we're approaching a large numbers. If we were between 0 and 1, that wouldn't be the case. But we're talking about very large numbers. So this is going to make it negative number squared is going to be positive, times 4 will still be positive, and a positive divided by negative, so it's negative infinity. So I encourage you to always look at these in more than one way. Look at them graphically, look at them algebraically, look at them numerically. All three methods should give you the same answer. If they do not, you need to go back and evaluate your methods and see what you've done wrong, because they have to agree.